For this example, we are given information about two different angles, alpha and beta, and we're asked to find the sine of alpha plus beta. So we're going to use these parameters to help us try and find this measure. So we're told that the sine of alpha is 5 over 13, and that alpha is in between 0 and pi over 2. So that means that alpha is in quadrant 1. And we're told that the cosine of beta is 2 rad 5 over 5, and that beta is in between negative pi over 2 and 0. So that's going to put beta in quadrant 4. We don't know what the measures are for alpha and beta. And so we're going to need to draw triangles, reference triangles, in order to do this problem. So let's start by drawing our triangles. So we're going to draw a triangle in quadrant 1. Triangle in quadrant 1. So here is our triangle, and we know that the sine of this angle, so this is alpha, we know the sine of this angle is 5/13. So the opposite side is 5, the adjacent side is 13, and we're going to need this other side. Sorry, the hypotenuse is 13, not the adjacent side. We're going to need the adjacent side. So we're going to use Pythagorean Theorem. So 5 squared plus b squared equals 13 squared. That's 25 plus b squared equals 169. Subtract 25. B squared is 144. So that means that b is 12. So it's a Pythagorean triple. 5, 12, 13. And then we need to draw a triangle for beta in quadrant 4. So we'll draw our triangle in quadrant 4. So again, triangle in quadrant 4. And this is beta. That's a right triangle here. All right, and so we know for beta, we know the cosine is 2 rad 5 over 5. So the adjacent side is 2 rad 5. The hypotenuse is 5. So we need to find the opposite side. So again, Pythagorean Theorem says 2 rad 5 quantity squared plus b squared equals 5 squared. So when you square this, you square the outside value and you square the radical. So we get 4 times 5 plus b squared equals 25. That's just 20. So 25 minus 20 is 5. So b squared is equal to 5. So that means that b is the square root of 5. So this is rad 5. So now we have our two triangles, and we can then now find the sine of alpha plus beta. So if you recall from the sum formula for sine, the sine of alpha plus beta is equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. So we're going to look at our triangles. Sine of alpha, so that means we're going to use this triangle here. The sine is the opposite over the hypotenuse, so it's 5 over 13. And then cosine of beta, so again we're going to go to beta. Cosine is 2 rad 5 over 5. So 2 rad 5 over 5. And then plus the cosine of alpha, so alpha is here. Cosine is 12 over 13. 12 over 13. And then the sine of beta. The sine of beta is the opposite over the hypotenuse. Now, for this measure here, rad 5, it's going to be negative because it's a negative y value. So we're in the fourth quadrant. The sine is negative in the fourth quadrant. So this is going to be negative rad 5 over 5. And now we're going to take these products and simplify. So 5 times 2 rad 5 is 10 rad 5. And 13 times 5 is 65. 12 times negative rad 5 is negative 12 rad 5. And then our denominator is the same. So we have a common denominator, so we can put these together, and we get negative 2 rad 5 over 65. So this value here is what the sine of alpha plus beta is. So we never actually found out what alpha and beta were. We didn't need to, but we could use these reference triangles to find this value here. in this next part, using the same two triangles and using the same information, we want to try and find the cosine of alpha plus beta. So the cosine of alpha plus beta, that equation is the cosine of alpha times the cosine of beta minus, the sum is minus, sine of alpha times the sine of beta. So if you look at the first triangle with alpha, the cosine of alpha is 12 over 13. So 12 over 13 times cosine of beta is 2 rad 5 over 5. 2 rad 5 over 5. All that minus the sine of alpha is 5/13. And the sine of beta is going to be negative rad 5 over 5. So again, take these products. 12 times 2 rad 5, that's 24 rad 5 over 13 times 5 is 65. Minus, or actually it's going to be plus because it's negative 5 times negative rad 5. So it's going to be plus 5 rad 5 all over 65. And again, we have a common denominator, so we can just take this sum. And we get 24 plus 5, that's 29 rad 5 all over 65. So this is the value of the cosine of alpha plus beta.